Hello guys, welcome to another video from 2IIM. In today's video, we'll be discussing the syllabus and in a very definitive, comprehensive sort of a way so that those of you who are preparing for CAT2025 can find all the things that they need in one video as far as syllabus is concerned. So first, let's have a look at what is the official syllabus as per CAT. Now here's the kicker. According to CAT, there is no defined syllabus. Okay, so there's no official syllabus as such. The convention says that mathematics up to class 10th is what they ask in the quantitative ability section of CAT. But if you go to their website, the official CAT website, and if you go through their FAQ section, of course, they very clearly state that there's no defined syllabus if you're preparing. So whatever knowledge of the syllabus that we have is only empirical. This is based on patterns, based on conventions that not only us, but like various people who have written this exam and what they have observed. So these are all based on these patterns that we have identified. So there's no official syllabus. And if somebody says there is an official syllabus, they probably don't know what they're talking about. Okay, so there's no official syllabus, and the syllabus is basically whatever they feel like, whatever kind of questions CAT paper setters feel like throwing in, they're at absolute liberty to do that, right? So I'm not sure how many of you watch The Boys, but this quote from The Boys is very appropriate. So there's no God. That's what the character says. This person right here. I'm sure you guys know who he is. So he says there's no God. The only man in the sky is me. And yeah, CAT question setters, they also live by that philosophy. Okay, the only man in the sky are the people who set CAT. All right, you can't question them. You can't ask them, oh well, this is not exactly 10th, this is 11th standard syllabus. They don't really care. Okay, so the aim is to prepare in such a way that you have a comprehensive understanding of everything that has come in the past, and you can only hope that they don't rock the boat a lot when it comes to the latest edition of the exam. All right. So we'll just briefly have a look at all the sections. So there are 3 sections, and the number of questions and even the total time can be changed. So up until 2020, that is before 2020, CAT had a 3-hour format, and they had a different number of questions per section. Now they have shifted to a 2-hour format. So it's 40, 40, 40, 120 minutes, which is 2 hours. And the number of questions, these keep changing. So for CAT 2024, the number of questions in DILR went up by 2. So this used to be 20, it became 22. The order in which your VARC questions appear on your screen was also altered. So the verbal ability questions, conventionally, usually they come right at the end of the paper. But to those who wrote the exam in 2024, the verbal ability section was scattered throughout. So once again, to iterate my point, they can do whatever they want. All right, so you can't really argue. You can't really say, hey, you guys did something different in 2023. Why did you guys change it in 2024? They are at absolute liberty to do that. They're not answerable to anyone. So it's best that we prepare ourselves in such a way that we are ready for any kind of curveballs that are thrown our way. Okay, guys, so before we jump into arithmetic and before we jump into all these different subtopics, let's look at how the number of questions that are asked in quants, how they distribute among these 5 subtopics. So arithmetic occupies the lion's share, followed very closely by algebra. And then you have geometry and mensuration. And then you have number systems. And then at the end, you have modern math. So if you look at the number of questions asked, this is a consistent 8 to 9 questions which were purely arithmetic in nature. Algebra 2 is not far behind, around 7 to 8 questions were purely algebra. Now, if you're somebody who's watching this, say in October 2025, or say in September 2025, this year, you may not have time to go through all 5 of these topics. Okay, maybe you've started very late for whatever be the reason. You're not in a position to go through all of these in great detail. If times are that dire, what we would suggest is please focus on arithmetic, algebra, and if you can, geometry. Please focus on these. Try to maximize your score here. Don't worry about these two. Okay. You may not get 99.5 plus. You may not even cross 99 percentile. But if you have a very good grasp over these three, you can very realistically aim at a 90, 95 to 99-ish. It's possible. It's very possible. Moving on. This was the split last year. And this has been the split over the past few years. And if you compare this to the table we saw just before, there isn't much of a change. Arithmetic again occupies most of the space, followed by algebra, geometry, and then number systems, and then modern math. So this has been the trend. Arithmetic does constitute 35 to 40% of the questions, and then algebra is another 30 to 35%. So if you add the two, 70% of your questions, 70 to 75% of your questions are either arithmetic or algebra or a mix of both. So if you're somebody who doesn't have time, you could focus on these two, do just these two extensively, reach a very good level here, and you can still maybe get a 90 percentile, 95 percentile in quants alone. It's possible. Okay. So now we'll move on to the individual subtopics themselves, and we'll start with arithmetic. Now, arithmetic, like I just said, highest weightage in CAT Quant. Okay, super important. You cannot skip arithmetic. It's a fool's gambit to skip arithmetic and think you'll be fine in quants. You won't be fine. You will have to do arithmetic. Now, the silver lining is that it's very logical. Sure, it does rely on some formulas, but the underlying logic is more thought-based, more understanding-based. It's very common sense. Arithmetic questions are common sense. If you are not afraid of numbers and you're quite comfortable with them, or you're comfortable with them to a reasonable degree, arithmetic should not be a problem for you. With enough practice, I personally, in my experience of teaching, I have seen all kinds of students do well in arithmetic. Okay, it's not a bar. The difficulty of these questions conceptually is never that high. Some of them are really easy. So arithmetic is something you should start with, and you should really get good at this, because most of your questions are going to be from arithmetic, and these are easy to solve. They might be lengthy, but conceptually they're easy to understand and solve. So you should be focusing on arithmetic. Like I just said, easier to solve compared to algebra and geometry, where things can get tricky. All right, so these are the topics. You have percentages. Now, percentages, you have to be handy with converting fractions to a percentage, knowing what a percentage is. If I give you two fractions and I ask you which fraction is bigger, you should be able to tell which fraction is bigger. Now, obviously, CAT wouldn't give you 1/2 and 3/4 and ask you which is bigger. Obviously, 3/4 is bigger. And also, gone are the days where they would ask you straight direct questions on percentages alone. Percentages almost never get a direct question in CAT. Percentages are used in all these various different topics. So if you are handy with percentages, you would find the rest of these topics easy. So percentages is more like your prerequisite. You have to be good with percentages. You have to get comfortable with percentages. It's an absolute must. So it's very elementary. If you skip this, might as well skip CAT. There's no point. Now, profit, loss, and discount, again, you have to be comfortable with the concepts of cost price, selling price. Profit is selling price minus cost price. You need to understand the concept of discounts. You need to understand the concept where, say, a shopkeeper buys 4 items and then he sells 3 and gives you 1 for free. So, what is his profit there? All these kind of variations you have to get comfortable with. And the difficulty level of these is generally moderate. Sometimes it's easy, sometimes it's moderate. At times they may complicate this by introducing linear equations into it, or introducing an optimization problem into it. All right. Time, speed, and distance, you have to be comfortable with relative velocities. You have to be comfortable with tracks, people running around tracks. You have to be comfortable with boats going upstream and boats coming downstream. You have to be comfortable with, basically, in a nutshell, you have to be comfortable with the idea of relative velocities. So if you're comfortable with the idea of relative velocities, this should not be a difficult topic for you. Then going to time and work, again, if you're comfortable with unitary math, if a person takes 10 days to finish the job, how much work does he do in 1 day? It's 1 by 10. Or the rate at which this person does work in a day is 1 by 10. If you're comfortable with this concept, time and work is a piece of cake. But when I say comfortable, you must be absolutely comfortable with this concept. Now, what I gave you was a very simplified example. Of course, the questions are complicated, but if you have a very solid grasp on this particular concept, time and work is not a problem for you. Averages, again, these require work. It's not an easy topic. It takes work, but if you master it, you can do whatever they throw at you. CAT can test you in tricky ways on averages, but it's a topic which can be mastered. With some effort, you can master it. Mixtures and allegations, they have an overlap with averages, because mixtures and allegations, basically it's a fancier way of saying average. When you mix two things, the average comes to like between the two quantities that you're mixing. So again, if you're good with averages, you get good with mixtures and allegations, vice versa. If you're good with this should not be a problem. And finally, you have ratios and proportion. Again, kind of like percentages, they'll never ask you direct ratio and proportion problems. They won't ask you what is 3 by 5, or if A is to B is 2 is to 3 and B is to C is 3 is to 7, what is A is to C? It's obviously 2 is to 7. They won't ask you a very basic question like that, but these are more application based. You'll be applying these in these questions, right? So arithmetic is like a building block. Please begin with arithmetic. Try to master this ratios and proportion and percentages first, and then move on to these topics, because these two are your building blocks for this module. Now, strategy, I've already discussed a few bits with you. You'll have to practice converting fractions to percentages and vice versa. You'll have to practice multiplications, doing them in a faster way. Now, some people place a lot of faith in Vedic math, and it's a legit science, it works. But the problem is you have to get really extremely good at it, so that you can trust yourself with those techniques in an examination setting. We have been doing 2-digit by 2-digit multiplication ever since we were very young. So that's a technique that you've been using for 20 years now, or maybe 15 years now, 15, 16, 17 years now. Would you want to ditch that technique to apply something that you learned and have practiced nowhere near enough as you have practiced 2-digit multiplication? I don't think so. So Vedic math is good, but please, if you're doing it, you have to get super good at it. Okay, you can't be decent at Vedic math, you can't be good at Vedic math, you have to own it. If you own Vedic maths, sure, multiplying 2-digit numbers, you could do it the Vedic math way. But otherwise, just try memorizing tables up to 20, tables of 20 up to the 20th multiple, right? So up to 400, okay, all tables of 20. So you shouldn't hesitate when somebody asks you what's 17 into 3, that's 51. Okay. So familiarize yourself, make yourself comfortable with these tables. Squaring, there are shortcuts, right? Get comfortable with those. Another thing you have to be comfortable with is converting word problems into equations. You have to get comfortable with equations. If you're somebody who's averse to equations, you have to disabuse yourself of this fear, of this false notion that equations are something very tricky or something that only math Olympiad geniuses are doing. I don't need equations. No, you need equations. You do need equations. And you should be very comfortable converting word problems into mathematical equations effortlessly. Now, another thing that you have to be good at is using logical shortcuts for ratios, percentages, and time work problems. Like I said, I had discussed the time work problem with you, right? Unitary method. So if a person is doing work in, say, 20 days, how much does he do in 1 day? So that's 1 by 20. And that becomes your base for trying to figure out what the question is asking you. So the question could be, if a person does, say, 20 days to do one work, if there are 5 such people and they work for 5 days, right? So how much work is getting done? So you'll be like, okay, fine, one person takes 1 by 20. So there are 5 people. So each day it is 5 by 20, so 1/4. So 1/4 of the work is done by these people each day. So the total number of days would be 4, right? So I was actually wrong. It won't even take them 5 days. They'll finish it off in 4. So that's the kind of comfort that you guys need to get with ratios, percentages, right? So that should be your aim, to be able to think of a given problem in multiple ways. And that will come with practice, okay? There's no shortcut. That comes with practice. Now, algebra. Algebra is something a lot of you have a great deal of irrational fear of. People are afraid of algebra. People think it's scary. Most of the people who think this way had not so great teachers back at school, okay, who put the fear of math in them, who put the fear of algebra in them. Algebra is a very beautiful topic if you're willing to attempt it, to read it with an open mind, if you come from a non-tech, non-engineering background. So the weightage is high, as we had discussed, right? It keeps popping up in CAT papers. It's never less than 6 to 7 questions each paper, all right? So it's huge. You skip algebra at your own peril. That's what I tell my students, okay? You can't be lax with algebra. You have to get good at it, okay? If you're aiming for the top percentiles, if you're aiming for 90 plus, 95 plus in math, and if you're aiming for a 99 plus overall, arithmetic alone won't save you. You have to invest time in algebra, right? The good thing about algebra is there are formulae, but algebra more often than not involves some kind of logical trick. You may rearrange terms, bring some term to the left-hand side, take others to the right-hand side, and suddenly the equation is simplified. So there is there's not as much formula application as, say, in geometry. You do need some formulas that you must be remembering, but algebra is more about understanding, more about how you can manipulate the formula, the equation logically. And a lot of questions can be solved that way. And once again, you'll have to be comfortable with converting You'll have to be comfortable with converting word problems into equations, okay? Algebra does that a lot, all right? A lot of problems that you'll practice in algebra would be of a word problem format, okay? Somebody had a certain number of sheep. He gave half of them away. Then he gave a third of those away. And then he was left with 5 sheep. So then you have to back calculate. You can use a variable, right? Do the math and figure out what x is or what y is. So word problems are gonna be here. If you hate word problems, you're not gonna get lucky. Arithmetic involves a lot of word problems. Algebra involves a lot of word problems. So ditch your inhibitions, ditch this prejudice that you have against word problems. Please get comfortable with it. Might as well, right? Okay. Now, these are the topics that are asked in algebra. All right. Linear and quadratic equations. Again, this is basically your ability to form a linear equation. And quadratic equation, you have to get good with the properties of the roots, right? Difficulty level is moderate. These are not easy, but they're not very difficult to understand. If you give it enough time, this should not be an issue. Functions and graphs are, think of these as the percentages or the ratio and proportions of algebra. These are your building blocks, okay? So begin with functions and graphs, then move on to linear and quadratic equations. Get comfortable with graphs of very common functions like the sine function, the cosine function, the tangent function, the square function, the cube function, the natural logarithm function, and e to the power x. Get comfortable with their graphs. If you understand their properties really well, a lot of the high quality questions would cease to be difficult if you can draw a graph. And it's a superpower. It simplifies things to the point that you think it's a cheat code. All right, so please focus on functions, please focus on graphs. Crucial, very important. Same goes with logarithms. It seems like a challenging topic, but if you give it enough time, the rules are very straightforward. The base changes, swapping bases. If it is, say, log b to the base a, then the inverse of that, like 1 by, if you basically, flip it on itself, and that becomes log a to the base b. So things like that, their properties and questions test you on those properties only. Very rarely do questions overcomplicate logarithms, okay? If you know the properties, you should be good. Inequalities and modulus by far has the potential to be the most challenging, subtopic here, because there are a lot of areas, there are a lot of roots which are like laced with banana peels, okay? So if you're walking through, you're solving a question, the chances of making a silly mistake here, the chances of making conceptual mistakes here are very high. All right, so you need to be thorough with your understanding of inequalities, with modulus. When can I use a square? Can I use a square instead of modulus of a? The different kind of solutions that I can reach. This involves a lot of practice. I'm not gonna sugarcoat this for you. Must practice inequalities religiously, okay? Thoroughly. You cannot take this for granted. All right, even if you think you've become good at this, no, you've not become good at inequalities. There's always a question which will shake you or shake your understanding to its very foundation, and that's a good thing because that's how you learn. Okay, so inequalities, sequences and series, very formulaic. If you know the formulas, if you know the AP formula, GP formula, 90% of the questions can be done. Okay, they're relatively straightforward. Polynomials and factorization has a lot to do with linear and quadratic equations. It's an extension of quadratic equations. Quadratic equations is for equations with the highest power of 2. A polynomial takes that to an nth power. Of course, they won't ask you to factorize a polynomial of power 5 or power 6 or power 7. If they give you a higher power, there's a trick somewhere. So you have to work on that, right? So the tricks come from quadratic equations, your understanding of cubic equations. So and a lot of these tricks have to do with graphs. If you understand how a polynomial works, if there are if the power is n, there should be theoretically n roots. Then it should meet the number line. If it meets it n times, there are n real roots. If it doesn't meet the number line at all, there are n imaginary roots, so on and so forth. Okay, so that kind of understanding is polynomials and factorization. If you have a decent understanding, you can solve most of the questions that come from here. Okay. Now the strategy, once again, you have to master quadratic and linear equations first. Okay, they form the base for other topics, and I would say even master functions and graphs. So these two combined form the base for the rest of your algebra. Okay, so master linear equations, quadratic equations first. Then learn logarithm properties. Very useful, very handy, because the questions are straightforward if you know the properties very well. And understand graph transformations. Understand what happens if my axes of my coordinate system, if they are shifted, or if they are rotated. These are high level applications. I'm not saying this is bread and butter algebra. This is going to the more difficult side. But if you can understand all that, which doesn't take a lot of effort, it's intuitive. If you can get it, if you can understand it, great. Your grasp on algebra goes up multifold. All right. And you have to get comfortable using the number line for visualizing problems about inequalities and modulus. Start drawing the number line whenever you have an inequalities problem or a modulus problem. It will make your life a lot more easy. If you don't do that, you're kind of operating in the dark. You're operating from a very algebraic point of view. You're not putting this, and you're not giving it a real world meaning. The moment you use the number line, you're putting it on paper. You can actually see the equation. You can see the graph. You can sometimes even intuitively rule out the wrong options and be like, okay, listen, the range can't be here or the range can't be there. You'll understand more as you solve algebra. But yes, please get comfortable with drawing the number line. Okay. Now comes the massive, huge part of quants, which is geometry. Huge, not because a lot of questions get asked from geometry. Huge because the syllabus is vast. The syllabus is massive. The proportion of questions that come from geometry are not in keeping with the size of geometry. So they ask a fair bit of questions. They ask you, I think, 3 or 4 questions each year in each slot, and that is around 9 to 14%. So if you don't have time, if you're looking for a shortcut, maybe you can skip geometry, maybe read up on the basic parts, skip the more complicated sections. But some people do skip geometry and they end up doing well on the quants section in CAT. So it's an option, but I recommend if you have the time, please read it. Might as well read it, because it's a useful topic. Because sometimes you might bank on algebra, you might bank on arithmetic, and you will find out that the paper has very tricky questions in algebra or arithmetic. So the predictions that you had for the exam, that I'll get X number of questions, I'll get X number of marks from these 2 topics, sometimes that can be thrown, right? That can be thrown for a toss. Then what do? Then what's your backup? Geometry can be your backup. If you know geometry, if you have studied this, out of the 4 questions that are asked, maybe you can wing 2. That's 6 marks. So this can be an excellent buffer if your strategy is to just do arithmetic and algebra. Learning geometry gives you that extra protection. Okay? And of course, it goes without saying, if you're trying to aim for a 99 plus score in quants, you have to read everything. You have to read geometry. You have to get good at geometry. Okay? So there's no wriggling around that. Okay? Now, unlike arithmetic, or, well, I should say just unlike arithmetic, it requires also an intuitive understanding of shapes, of spaces. If you can visualize this well enough, you are 30% through with geometry already. These are mostly formula-driven questions, okay? They don't overcomplicate geometry because they can't overcomplicate geometry. And still say this is 10th standard stuff or this is 11th standard stuff. They can overcomplicate it, but then the difficulty jumps and it makes a massive leap. So they are constrained. When I mean they, I'm talking about the people who set CAT. They are constrained. There's only a certain number of properties they can use, and they can twist them around and make a real Frankenstein monster of a question. But even then, you can see the properties in action. If you know the properties well, you can unravel the mystery and you can solve the question. Okay, so they don't get generally very complicated. If you're comfortable with the properties and if you're comfortable with the formula, geometry, you should be doing well. Okay, now the syllabus, like I said, is vast. You should ideally start with lines and angles. Try wrapping this up. Basic things, parallel lines, and say there's a line that is, cutting across, and these two lines are parallel. Then which angles, are the same, which angles add up to 180, all that kind of stuff. Okay. Then you'll go to triangles. Triangles again are very easy if you know what you're doing. Types of triangles, Pythagoras theorems. Emphasize more on the properties of triangles, all right, and this can be done. So I would say lines, triangles, and circles, if you do these, geometry is 70 to 80% done for you. But if you really are aiming for that top score, you have to do everything. So circles, again, you have theorems on cyclic quadrilaterals, you have tangent secant theorem, you have properties of circles which are very interesting from a purely mathematical, academic point of view. And then you have quadrilaterals and polygons. If you do circles first and then move on to quadrilaterals and polygons, there are a lot of concepts which overlap. So you will find that interesting. You will see a lot of concepts which are derived from here, and you will see a lot of concepts here which come from polynomials. Sorry, not polynomials, polygons. Okay, my bad. Pardon. There's also coordinate geometry. Very formulaic. It's like you take geometry and you give it a very algebraic treatment. So a lot of equations. It ceases to be geometry in a visual, spatial sense. You're not worried about properties anymore. You're worried about formulae. You're worried about slopes, lines, intersections, shortest distance of a line, of a point to a line, stuff like that. Slope calculations and all that. Okay, it's doable. Coordinate geometry is doable. Formulas are few. They usually ask those formulas if they ever ask formulas. So it's a nice area that you can quickly get in your bag. Mensuration is about measurements, area of a square, cuboid. Then things get more complicated. Sphere. Then you have truncations happening, like a cone which has been cut off at the top. So now you have like something which looks like a frustrum, area of a frustrum, and all that stuff. Again, it seems intimidating, but it can be done. It's mostly formulaic. Questions are real life applications. If a painter wants to paint this room, how much money would it cost him? In terms of, say, 80 rupees per square meter. So you figure out the area of the room and you get your answer. Stuff like that. Even CAT doesn't experiment much with mensuration. So it's pretty straightforward. Trigonometry, you have to get good with basic ratios. You have to get good with identities. You have to solve a lot of questions in trigonometry to reach that level of comfort where you can say, I'm okay with this. I'm good with this. Okay. Transformations, nowadays, these are very rarely asked. But if you're looking for completion, you want a holistic prep of quants. Transformations are a few extra steps. If you understand how translation works, if you translate axes, coordinate axes, if you rotate coordinate axes, right? It just gives you a little more comfort and confidence, okay? So this is geometry, more or less. I think I've covered everything in geometry. Yeah, okay, all right. So it's vast, but it's conceptually not that tricky. So if you give it some time, you can actually, bag some of these sections. You can actually bag them and do well if they're actually asked in the exam. Okay. So like I said, memorize key formulas, key theorems. The geometry is all about properties. Maintain a book, write these properties down, revise this daily before you go to bed. Okay. Then this you should be doing especially 60 days before CAT, 70 days before CAT. Start doing this. You'll see a marked improvement in your mock scores, and you'll see a marked improvement in how comfortable you are with geometry. Now draw diagrams wherever possible. Geometry is really diagram heavy. Okay, and frankly, if you can do this well, you can sometimes avoid a lot of extra calculations. You can even avoid making silly mistakes if you're good with diagrams. Practice past CAT questions because, this is a general advice for all the topics, but geometry, they don't experiment much. So there are, like I said, a certain number of properties and they quiz you on those properties and they don't experiment much. So if you practice past CAT questions in general and specifically for geometry, you have a very high chance of solving whatever is thrown at you. Now NS stands for number systems, and number systems is a topic which a lot of people don't understand intuitively. There are some tricky bits like remainder theorem, Fermat's little theorem. Those bits do get a little complicated, but if you back yourself, if you're willing to learn the science behind it, number system like geometry, the question types don't change, more or less. Again, they're constrained by certain properties of numbers, so they can't ask you whatever they like. If the question appears complicated, there's a trick behind it, because otherwise say for instance they're asking you how many zeros does some number to the power 3000 have. Now obviously CAT doesn't expect you to raise that number to the power 3000. There's some trick behind it. If you know the trick behind it, you can easily figure out the number of, well, not number of digits, but maybe what's the last digit, what's the unit digit, right? So stuff like that. The weightage is low, less than 10%. Recent years it's been low, but again, one or two questions, if you know the formulas, if you know the theory, why leave it? Okay, if algebra is super complicated, if geometry is super complicated for your slot, and you see this number systems question and it appears doable, do it. Why leave that chance? So like I said, it's never a dominant topic, but it has its uses. Sometimes number system creeps in geometry, in algebra, it creeps in sometimes quite a bit. So it has its uses, right? DI, data interpretation, your DILR section, sometimes really knowledge of number systems helps. It does help, okay? It is rare, but it helps. All right. If you are well prepared, these can be very quickly solved compared to say some very lengthy arithmetic question where you're supposed to calculate the profit, where like say a certain good has been marked up 3 times. They've not given you the percentages, X, Y, Z. It becomes very messy. Instead of wasting your time on questions like that, you can very easily do number system questions if you're comfortable with number systems. All right. Now, this is the syllabus for number systems. And again, when I say syllabus, I mean the patterns of what we have seen. There's no actual CAT prescribed syllabus. This is what we have seen that is being asked for the past 20 years, which is what we are presenting to you. Okay. So properties of numbers, odd and even numbers, they have interesting properties. You know, if you add 2 odd numbers, you get an even number. If you add an odd number to an even number, you again get an odd number. Things like that. If you multiply 2 numbers, what happens? If you divide a certain number by another kind of number, what happens? Prime numbers, composite numbers have very interesting properties. And these are easy to know. If you can get a hold on these properties, most of the questions are doable. Okay, so most of the questions can be solved. Then you have divisibility rules. Again, if you know the rules for 2, 3, 4, 5, 6, 7, well, I wouldn't even say up till 17. If you know up till 11, you're good. You're good. You can do 99% of the questions that they ask you as far as divisibility is concerned. HCF and LCM should be your starting point for number systems. Basic building block, super useful everywhere else. if you have to do one topic in number systems, please do HCF and LCM. Don't do anything else. If you don't have the time, skip the rest, but do this, because this is going to be useful in DILR. This is going to be useful in arithmetic. This is not exactly arithmetic, but this will be useful. Yes, it can also be useful in arithmetic. There are questions which test you based on your knowledge of HCF and LCM. Super versatile, super useful. Please do read up, practice HCF and LCM religiously. And finally, you have remainders and modular arithmetic, right? So remainder theorem, Fermat's theorem, Chinese remainder theorem seem complicated, and to most people they do appear complicated. Actually are not. Need some time. You have to invest some time in this. But if you can grasp these concepts, do some questions. They're not that tricky either. They're not that tricky because they're formulaic. Fermat's theorem is a formula. Questions based on Fermat's theorem will inevitably bring up that formula. So if you know Fermat's theorem, you can solve this question. All right, questions. Okay. Now, what is the strategy? There are other things also. Base systems conversions, again, if you're comfortable with converting, say, decimal to binary or binary to hexadecimal, the science is the same. If you know the science behind base system conversions, very powerful, because people generally have an aversion to base systems. They find these questions naturally tricky. So if you can work hard here, if you can get these in the bag, you're already ahead of most of your competition. Okay. I was talking about last digit calculation before. This is what I was talking about. Say you're raising a certain prime number to a very high power. If you know the fact that powers cycle after a certain number, you can use that to figure out what the last digit would be. Right, so 3 goes as 3, 9, 7, 1, and then 3. So 3 cycles back after every fifth power. 3 cycles back to 1. Right. So if you want to figure out what 3 to the power 11, what their final digit could be, you can break that down into 3 to the power 5 into 3 to the power 5 into 3. You know the last digit for 3 to the power 5 is 1. You know the last digit for 3 to the power 5 again is 1. So 1 into 1 into 3. Is 3. I mean, I could be wrong. Okay, I might have made some calculation mistake, but I've tried to explain the science behind it to you. All right. So that's cyclicity. Factorials is a very crucial part to number systems, and it's easy to understand. It's easy to understand. There are very few formulas involved. If you can grasp it, well and good, you're through. All right. Sum of digits, digital roots. Sum of digits is not seen. I mean, its direct applications have kind of gone down. Over the past few years, they have gone down, but at the same time, it's nice to know. It's a very basic concept. It's fun to know. Indices and surds actually tie in with logarithms. If you understand indices, if you understand surds, you can understand logarithms. Vice versa. They are interconnected in some ways. Again, these are not very difficult conceptually speaking. Conceptually speaking, the thing that you might find really difficult might be base systems and might be this remainder and modular arithmetic. The rest are okay. Conceptually, they should not be a challenge. Okay. Strategy, memorize divisibility rules, memorize prime numbers, say up to 100. There are ways to check if a number is prime 100. Memorize that, helps you in the exam. Right. Master remainder theorems, right? I told you Chinese remainder theorem, Fermat's little theorem, right? These things, they are super useful because from what I know, Chinese remainder theorem, questions based on that have been asked in CAT, okay? Questions like a certain number when divided by 17 leaves remainder 3, when divided by 13 leaves remainder 5. This same number when divided by, say, something else would leave remainder what? So that is your Chinese remainder theorem. If you know CRT, you can solve this in a very systematic way. Okay. LCM and HCF tricks. LCM of a numerator. How do you find out the LCM of two fractions? How do you find out HCF of two fractions? LCM, HCF, like I said, are very, very versatile, super useful. Please don't skip this. Okay. Again, base conversions, you can practice them, learn how to practice these. Learn how to do these by practicing them. Okay, so they strengthen your ease with handling numbers. Although this may be a little niche for some of you, this may be a little esoteric, but the remaining points are of great utility. Okay, so please, if you don't wanna work this, if you're out of time, maybe don't do this. Definitely do read on LCM and HCF, right? And definitely do work on divisibility rules and prime numbers, okay? Vital for CAT. You may skip the rest if you're running out of time, if you have like say a month to the exam, you want to revise, you don't have time to learn anything else. Yeah, so then you may have skipped the things that I mentioned. Modern math, people love to hate on modern math. People hate probability, people hate set theory, people hate counting, people hate permutation. Again, they didn't have the best of math teachers back in school. I get that. Luckily for them, these questions are not as frequently asked as the rest. The weightage is very low, 1 or 2 questions each slot. But these are based on logic. Okay, there are a few formulas, but they are mostly logical, right? So these are very logic heavy, and these are very useful when it comes to DILR. So DILR sets, quite a few times it has happened that if you knew permutation combination, you could very easily rule out a lot of possibilities. You could figure out how many cases or scenarios are possible. Okay, it helps. But otherwise, as a standalone subject for CAT, for Quant, maybe not as important as the other 4, but very useful applications in DILR. All right. So this is the overview. The difficulty here generally is high because we are not used to counting this way. We've been taught to count using our fingers, decimal systems, but we have not been taught to count using permutation and combinations, right? Frankly, because we don't use them a lot in real life, but also because there's this stigma that these are complicated, 5C2 is a scary number, what is 5C2? But once you realize that it makes a lot of sense logically, you will begin to see that permutation and combination is a very useful topic. So PNC difficulty is high, I agree, but if you can master it, questions, sometimes you can get them right. There is a caveat, there's no way of checking your answer. Okay, so you could do a PNC question, think you got it right, and you may have missed a case, and then the entire thing is like, totally wrong. Okay, so yeah, I get it from a input-output ROI perspective, not the best. I mean, at least PNC is not the greatest, not the greatest yield comes from PNC, but it's still useful. Okay, it can be useful if you master it. Probability is less difficult than PNC. There are some properties, if you know this, and this has a lot to do with set theory. If you're good with set theory, you're good with probability. If you're good with this, you'll get good with this. These two are very complementary. So probability, Bayes theorem, probability of 2 events. If this event happens, then what's the probability of this second event happening given the first event happened? Things like that. Okay. Difficulty is high, not very intuitive sometimes. Some questions are tricky. A coin falls on a chessboard. What's the probability that the coin falls squarely within any of the tiles? It's not intuitive, right? How do you go about solving that? But yeah, so the difficulty is high, so plan accordingly. Okay. Set theory and Venn diagrams, forget the difficulty. These are going to save your DILR. If you're not comfortable with set theory and Venn diagrams, kiss your DILR section goodbye. it's over, it's finished. Okay, if you hate modern math, I get it, but you cannot hate set theory and Venn diagrams. I don't care even if you hate set theory and Venn diagrams. Do it, because it is vital, it is super important for your DILR. Okay, so skip this at your own peril. All right. Now, binomial theorem, technically, yes, there have been some questions which have been asked, but over the years, we are seeing fewer and fewer questions that are directly being asked from binomial theorem. So you may skip it altogether, outright. Again, I would recommend that you go through everything. Each thing that I've discussed should be read, should be studied, should be given the respect it deserves. But binomial theorem, if you're running out of time, you have nothing to do. You have a lot to do, but little time. Please skip binomial theorem. Okay, it's barely any questions asked nowadays. Strategy. That is, if you do choose to do modern math, which anybody who's aiming at a 99.5 plus, 99 plus, you want to be that topper in quants, you have to do modern math. There's no running away. Okay, I have a 99.59 myself. I did all 5 sections religiously. I hate PNC, I hate probability, but I just gritted my teeth and I got through with it. Okay, so you'll have to do the same, and they help you in logical reasoning, DILR, like I said. Okay, and speaking of DILR, Venn diagrams and set theory, crucial, absolutely important. Absolutely important. I cannot stress this enough. All right. So the strategy is master PNC and probability, right? Master Venn diagrams, okay? Do as many questions as it takes, right? But you have to do well in these, okay? That's your key to doing well in modern math and also in DILR, okay? Now, where can you read and practice from as far as quant is concerned? Obviously, this video is from 2IIM. I work for 2IIM. I'm gonna always tell you, please come check out our 2IIM material. It's great. The quant material in particular is excellent. It's exceptional. Okay, and I say that because I was a student last year and I used their material and I got a 99.59. Okay, so it's a fact. But if you don't want to use our material, that's fine. There are a lot of great providers out there. There's no shortage. You can go and use their material. What I would tell you is, don't obsess over material as such. Most of the material out there is great. Obsess over the number of questions you're doing. Obsess over the quality of questions you're doing. Obsess over the fact that, or whether you have been pushed out of your comfort zone or not. Obsess over those things. Please stop obsessing about, that mock is tricky. Oh, this mock is not that tricky. I won't do this mock. I won't learn from that coaching. No, dude, the material is good. Sure, there's a spectrum. There's great material. There is, not so great material. But if you look at the material as such, as long as it's a reputed coaching, the material is going to be good. Okay? Stop obsessing over pointless things like material and start obsessing over real things like how many questions I did today. How many different type of questions have I come across in this topic? Obsess over those things. They will pay you a richer dividend. Okay? Now, the best practice, I would say, is PYQs. And you can find them on the internet. Our own website has them for free. We also have detailed video and text explanations. Go through PYQs, solve them, start backwards, start from 2024. Solve them all the way up to 2017. Okay, doing just that alone will take your percentile to the high 80s, early 90s. I'm not kidding. If you do this, and when I say do this, I don't mean doing it and forgetting it. I mean doing it, understanding the math behind it, and understanding the science behind what happened. Okay, if you do a question, say on probability, or say you do a question on number systems and you used Fermat's theorem. Now, work backwards, work with the question, change the question and see, can I still apply Fermat's theorem? Oh, if the two numbers were not co-prime, would I still be able to apply Fermat's little theorem? Oh, I can't. So the question numbers have to be co-prime. So I'm saying when you solve a certain question, dive into it, do a deep dive, analyze it, and then you can say I've solved a question. So if you follow that technique and if you do it from 2024 to 2017, all the quant questions, all three, 3 or 2 slots, believe me, you're already staring at a 90, 92, 93 percentile in quant already. And of course, there are materials out there. There are, amazing, coaching materials. There's all sorts of other supplementary material which you can use to further bolster your quant ability. Okay, and that will take you even up. All right. But as far as quant is concerned, practice, practice, practice. PYQ, PYQ, PYQ. Analyze, analyze, analyze. If you do this alone, you will still end up with a wonderful score in quant. Doesn't matter what your background is. It doesn't matter. Okay, it doesn't discriminate. Or it's immaterial. You could be a commerce grad who hates numbers. Do what I've asked you to do, and you will see a percentiles jump. Okay. Now, one thing that I ask our students to not do is avoid Vedic math books. Now, let me clarify. I'm not saying avoid Vedic math. Vedic math is legit, and it works, and it's wonderful. The problem is these books, they are huge, they're heavy, they contain hundreds of formulae. And the thing is, you don't need all of them. Okay, it's like reading those self-help books. Okay, you are feeling like you're going somewhere. You read this wonderful self-help book and you're like, oh wow, you know what, tomorrow I'm going to wake up and my life's going to be different. And it turns out their life is the same. Okay, Vedic math books give you that sense of false achievement. Okay, they lull you into the sense of, I've done a lot of work for CAT, I'm going to ace this exam. No, right? First of all, you're not going to remember all these formulae on the day of the exam. Secondly, in the actual exam, the pressure is so immense, you're going to start doubting everything you do. That happens to everyone, even people who get 99 percentile plus in quant, even somebody like myself who got a 99.17 in 2023 and I got a 99.59 last year. I doubt myself. People do that. Okay? There are times when I think, oh my God, like a square plus b square is c square. This is it, right? Am I not making any mistake? I do that. People do that. People who do really well in quant stop, and sometimes they're like, am I doing the right thing? Now the problem with Vedic math is, if you want to memorize a formula or two, that's okay. But if you go about memorizing 30 formulae, right? You gotta know them for sure. You must know them for sure. You can't mix match. You can't take two ideas, mix them together, and this will happen to you in the exam, right? If you're not sure that this was the formula, this was the technique, this was the way it was done, you can't take that risk. So in effect, you've wasted hours of preparation learning things that you eventually may not remember in the exam. And which is why I'm saying avoid Vedic math books. Whatever speed tricks, whatever speed formula you need, they're few in number. They're like 10 to 15 of them in total for quants. Okay, for the entirety of quants, 10 to 15 max to max. Okay, formulae or tricks as you call them, Vedic math based or whatever. Okay, you don't need any more tricks. All right. So guys, that was our discussion on the quant syllabus, on what you need to read, how you should go about, what sections you can target, what sections you maybe can leave and still walk away with a great quant score. All right. So thank you so much for being very patient with me. It was a really long video and I hope you gained some value out of it. And if you did, please like this video, please share this with your friends, and do subscribe to our channel. Thank you so much. I hope you have a great day. Thank you.